Sebastian.
Yeah, hello everybody, and thank you, John. Let me share. Oh, you have to stop sharing, please.
Sebastian, last week you were in New York Times, now you're in Wunderkind. What's going on there?
Yeah, just made the switch. And I just started, so I can talk much about what I'm doing, but Archie, can you stop sharing the slides, please?
Sure.
Okay. Thank you. And these are the slides. And I want to thank you, some of my team members at Wunderkind that joined the meetup today. Thank you for coming. Okay, so this talk is about setting up your laptop and your shell environment to work with Kubernetes and get productive fast. I'm mostly about setting up a Mac and using DSH. It's like you can apply most of what I'm going to say to something else, but I'm just focusing on the Mac. I know a lot of engineers are using that. And I'm going to skip some of the slides also. So first, I also put a blog post on Medium, so you can scan the QR code here to go to that. I will share the slides, but they are the same as the blog post. So, and I guess even the blog posts have a little bit more information into there. So you can use that as a reference and find all the links to everything I'm going to talk about in the blog post. So we don't have much time, so let's dive directly into that. So I'm talking about Kubectl here and the shell. I'm not talking about Kubernetes internals, API, how it's working. So like installing Kubectl, there is a few slides here, but you know that already. I hope you all have that already done. So let's dive directly in here. Kubectl, great. Kubectl get pods. You get like a lot of information. Everything is white or blue or whatever color you have in your shell. Sometimes it gets difficult to understand exactly or to get right to the information. First tool is Kubecolor. Very straightforward. It's kind of a wrapper on top of Kubectl. So you can use an alias, for example, and just use that. How you can see, there's a very good colors. It gets easier to get down to the stuff. Only one small problem with that is at the moment, if you use the some other commands I'm going to talk about, but CTX or NS commands that you can get from Krew, at the moment the default version will display everything in yellow. So I have a PR for that. It feels like this project is not very active at the moment. Nobody's answering. So you can go from my fork of the project, check out my branch and build yourself. You only need the Go tooling to build that. And then you will have like in yellow only the interesting stuff. So that's what you have here on the right. Okay, I'm going to skip this one. Only one thing I want to mention is here down the ulimit -n. It's the number of open file that you can have in your shell. It's 250 default in the latest macOS. It can be a little bit too less if you have a very big cluster with a lot of resources, and depending on the command, the Kubectl commands you're typing, if sometimes when you apply something and there's a diff going on, Kubectl will open one connection for every resource that needs to be patched or whatever. So if you have a very big cluster, you could end up with very strange errors like DNS errors from Kubectl that are totally unrelated to that. So that's one of the latest things that I found out like in the last few months. So change your ulimit here, and you can do that by default in your ZSHRC or bash RC. Completion, you all know that. What I'm using in my ZSH right now, OMyZSH. If you don't know that, and if you're in the shell on macOS or even in Linux, install that. It's very easy to install. It's just a curl command. It's going to ask few questions and install everything for you, and then you will have your ZSH RC, so per user. And so there is a lot of things going on that will enhance your usage of the shell. Specifically, this plugin line where you can add a lot of plugins that will enhance the shell specifically for these commands. So that also include auto completion, for example. Very handy and useful, so go with that. And OMyZSH comes with a theme, so you can specify exactly which theme you want to use. I was a user of the Agnoster ZSH theme, and I just discovered, and thanks to Anthony for that, the power level 10K. Again, very easy to install. I think it's one command install, and just go on the website, and you will have all the information. It's going to ask a few questions depending on how you want to do things, and it's even going to install Powerline font, one Powerline font for the theme. So you don't have actually to install the last one from the fonts here, the Powerline. You can still do that if you want, and you can still use in Consolata or VsCode font into, let's say, Visual Studio Code, for example. So you can do that, or just installing Power Level 10K will do everything that is needed for you. What you will gain with that, for example, out of the box. So this one is from the Agnoster theme, but you have the equivalent in the other theme. Is your command line customization at the beginning of the line. You can add a lot of stuff. Here I have few of my stuff. Let's say I was using AWS, so I had a project configured for AWS. So you can see that on the command line. You know, at every point in time where you are in your shell, in which folder. If it's a Git repo, you have at the end in green here on which branch you are, and you can add a lot of other different stuff here. You can add some stuff related to Kubernetes, like the context or the namespace you're in, the default namespace you selected. Definitely a very good helper when you're in the shell quite often. Then the next, Krew. Krew feels like Brew, but for Kubernetes. So it's a kind of a plugin manager for Kubectl. Again, very easy to install, and you can install that with Brew. And it will kind of add new commands to Kubectl. So then you can Kubectl Krew list and see what plugins you have already installed. Krew search to search for all the possible plugins that exist. And then Krew install like CTX, NS, Stern. Even Stern can be installed with a Krew now. So there's a bunch of plugins that I usually install by default. Who am I? Very useful when you have different contexts and you're using cloud Kubernetes. So you're switching from Google to AWS, and you have different authentication methods. So how the cluster see you when you're using a Kubectl, who am I command can tell you that, and who can is so very helpful to understand who can get pods, who can kill pods, or things like that. Who can tell you that very quickly. And there's a bunch of other plugins, up to you to dig into that. I'm going to focus here on two different and very specific, and that I use all the time. Is first one is CTX. So it's about context, changing your default context in Kubernetes. So KCTX will list all the context you have configured. That means if you go look into your .kube/config file, you will see you have a ton of like the file get very huge when you're working on different clusters, and this is a helper to be able to switch very quickly from one to the other. So it's kind of a shorthand to, instead of kubectl config use context blah blah blah, it's kctx and the name of the cluster you want to use, and bam, you switch from one cluster to the other. The other one is NS for namespaces. So like CTX, it's just a way to list and switch your default namespace. So KNS, you see the list of namespaces. Everything is blue except the default, which is yellow, which is the one selected. And then you can KNS kubesystem, for example, and switch from default to kubesystem as a default namespace, which is the equivalent as kubectl config set context current namespace equals something. So very short, very fast. Use that all the time. Setting up AWS. So I'm going to skip this one, and you will have all that in the blog or in the slides. Like few options. Okay, let's spend just like few seconds. AWS pager equals nothing. If you don't do that, and you usually AWS, I don't know, STS get credential or whatever command you're going to use, you may be paged. That means instead of displaying the information in your shell at the bottom of your shell, it's going to open an editor and display the information in the editor, and then you have to quit the editor, so you're going to lose the information to type another command. So removing that behavior, you can remove that by using AWS pager equals nothing. And the other one is browser equals echo. When you AWS SSO login, for example, it's going to try to open your default browser for you to do the authentication and get an ID and blah, blah, blah. So if you don't want, or if you're not using, or your default browser is not configured to do that, and you're using another one like Safari or Firefox, then by setting browser equal echo, it's going to display everything on the command line, and it's up to you to use whatever browser you want and get access to the token that you need. Again, that's a helper, but you should know that, AWS EKS update. And then there is the same thing for Google, and there is nothing very special in here. Stern, Brew installs Stern. Stern is, to me, the best log, the best tool for displaying Kubernetes logs. So it's the same thing as kubectl logs, and then you give a namespace and a pod, and then maybe a container inside the pod. Here with Stern, you don't have to go with all that. You can -n for the namespace, and then just give a keyword, and it's going to match all the pods that match the keyword. In this example, we have two different pods. So one is in purple, the other one is green. And then you have all the containers for each of these pods. So for example, the first one, we have API, Cloud SQL, Proxy, and Frontend containers inside the same pod. And then you can, if you want, on the command line, you can filter down to exactly one container, or even grab the pods from labels or things like that. So you can filter out, but it's very clean, and you have a direct understanding on which pod, which container, and then you have the exact same log as you would have with kubectl log. So that's what we have here. Kustomize, of course, like I'm not going to dive into Kustomize, it's too big of a tooling. You have the default Kubectl Kustomize option that is bundled with Kubectl. You don't have all the features when you're using the bundle version of Kustomize. So I usually install and have at hand the Kustomize binary by itself. So Kubectl Kustomize, and then the folder you want to build, or Kustomize build will do the exact same thing. It's just outputting the YAML from the templating system or the overlay system. So that means you need to pipe kubectl apply, for example, if you want to apply the resulting thing. So keep in mind, you may have some slight differences between Kubectl, Kustomize, and the Kustomize binary. I'm skipping all that. We don't have time for that. Then interfaces. There are two kinds of interfaces, or let's say 4 kinds. Command line interfaces, that's the case for K8s. So you store that directly in your shell. Everything is running locally on your laptop and is like putting some requests against the Kubernetes cluster. So again, very easy. You can pick up one namespace or different namespaces. You can change the context or ensure read-only if you don't want to mess something with the cluster. It's a very neat interface. Sometimes you need to have want a quick look at the cluster and know exactly what's going on, which version are at play, and things like that. That's very fast. You can do that with that, and you can access logs for each. So you can select the pod and go to logs. You can attach to the pod. You can even kill the pods if you want. So very easy and fast way to get access to the cluster information. Then the other kind is Lens. So Lens is a UI application. Again, you can install that locally in your apps. There is nothing to install on the cluster side. And so the application is going to use your contexts to reach the cluster. So the cool thing here is, the two cool things with Lens is, first, it's very easy to switch from one context to the other. The second one is that it knows about the custom resources definition. So if you have custom resources, you can list them, access them, edit them. So again, great tool if you're more visual than a shell user. Virtual Studio Code extensions. So there's the Kubernetes one, you all know about that, and there's a bunch of sub-Kubernetes extension that you can add. It will make it easier to create Kubernetes resources by hand if you're into that. That means easily type API version, for example, RBAC, blah, 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 and it's going to propose some of the kind metadata and things like that. So YAML, just to highlight the YAML files. And Indent Rainbow, I got that from Mel, an engineer at the New York Times. It's I hope you see that on the screen capture here, but it's going to put different colors for every tab or every indentation in your files. So it makes it very easy when you're doing some YAML to understand where you are in your indentation. So very interesting when you have very big YAMLs. Next, local clusters. Again, I'm not going to dive into all that. There's 3, I think, listed here in the slides. Kind, it's kind of the default one now. What I'm seeing works with Docker, Podman, very cool. So this is going to create a small cluster, Kubernetes cluster locally on your laptop. So when you want to test something or do breaking stuff, that like you can spin up a cluster, do something, break it, and remove it. And there is a lot of customization and very simple to customize. Change the versions, the number of nodes, the node pools, and whatever with Kind. The other one, K3s. Again, very easy to use, work both on ARM 64, AMD 64 and ARM. So again, another option, very cool, and check it out and fun for yourself. I'm not promoting any of these over the other. Minikube is the oldest, work with a lot of stuff, maybe a little bit more complicated to install and bootstrap, but again, great tool. Bonus tooling. These are 3 small applications that I recommend having if you're working with a production. Kubepug is an application to check either local resources you want to deploy or resources in a running cluster, and check if those resources are working with a specific Kubernetes version. So let's say you're planning to upgrade your cluster for 120 to 121 or 122. This application will check the resources in the cluster and will tell you, okay, this is deprecated. This is deprecated, but still work in this version and will be removed in 1.25, for example. So that's a very cool tool to have before you want to upgrade a cluster, or if you're using a Helm chart, for example, and before deploying the chart, you want to ensure that the chart is not generating stuff that is not working with your target cluster version. So you can, again, generate the YAML, use the YAML with kubepug, and make the server check to ensure that everything is fine. You know, the API version like apps v1 that or beta something that was deprecated. This tool will tell you that. Dive is an application to inspect Docker images. So if you're building Docker images from your code and want to use that in Kubernetes, that's a way to dig into the image, into the different layers, understand what each layer is doing, and usually it will give you some advice on how to reduce the image size. So again, a very cool tool for Docker images. And Dasel. Dasel is like JQ or YQ and support of a ton of different files. So if you're into, you have a YAML file and you want to update, or a JSON file and you want to update something, or mass update, or change all the image versions, for example, this kind of stuff, Dasel is here for you. So whatever you're doing with JQ, usually Dasel will do it as fast, if not better, and can also like be used to translate JSON to YAML, for example, and vice versa. So it's one tool to rule them all. It's one binary. It's made in Go. Very cool. So here are a few comments for Dasel, for example. Dasel select from your deployment file, and what you want is spec templates, spec containers, but you want the image name of the container named auth inside this deployment spec. So you would do that with JQ, but you can do that with Dasel, and you can actually update this. So instead of doing some Kustomize, if you want to do something very fast, then you can do that with Dasel, like changing the number of replicas, for example. Very easy to do and to use. So this is just here for reference. I'm not going to dive more into that. Containers without Docker. That's been a very big matter in the last year, since Docker decided that Docker Desktop will be a pet product for enterprise. I'm totally recommending Colima. So there is one project named Lima, and finally they made Colima. Very easy to install, as you can see here. Brew install Colima. Brew install Docker will install the Docker command line. So you can do that. It's not Docker Desktop. It's totally, you don't have to pay, and you can still use the Docker command line. In the background, Colima will do whatever is needed. So there is kind of a Docker daemon running somewhere. It can also spin up a Kubernetes cluster. So if you want even a faster way to start a local Kubernetes cluster instead of Kind or K3s, you can just start with Kubernetes, and you can switch from the runtime from Docker or Containerd. So if you are using Containerd, we're going to see that once you install, Colima status will tell you it's running, it's using the Docker runtime. It's working, of course, it's working on ARM platform, the new M1 Max. And the configuration is here in a .kolima YAML file. So that's things that you can set on the command line the first time you run, or you can kolima stop, update this information, and then restart. And it's going to recreate a cluster and do whatever you want. So you can change the Kubernetes cluster, for example. If you're not using Docker, then there is kolima is also providing the nerdctl command, so you don't have to install nerdctl command. Know that it's just brew install nerdctl if you need it, but kolima is bundling that for you. So then instead of using Docker do something, it's kolima nerdctl, for example, kolima nerdctl ps. And if you start at Kubernetes, then Kubectl CTX will give you have a new context named kolima, and with like core DNS metric server running by default. The other one cool tool is Podman. So Podman is even more like, I call that a Swiss Army knife from Red Hat. It does almost whatever you may want to do for Docker. So it will replace Docker for everything that you may want or need to do, even like exporting images from locally and in different kind of formats or whatever. Working on the M1 also, very cool tool. And that's it for the slides. So I'm going to go back here to this if you want to take other pictures of that and get access to the blog post with all the links, all the same information that we had in this talk. Everything is here. So that should bring you to like full speed with Kubernetes on your desktop.
Sebastian, you shared all your secrets, all your dirty secrets. How you work?
Yeah.
Thanks a lot.
Awesome. Thank you very much, Sebastian.
So
if anybody has any questions, then please drop them in the Q&A. We have about a minute before we got to move on to Peter. Sebastian, do you know offhand if kolima and Podman require VMs on Mac M1, or do they just run natively?
So sadly,
I heard natively it's running already for M1.
I don't think so, but I don't have an M1 Mac.
My
so
colleague just confirmed that it's working.
Okay, then great, even better.
Yeah, it's working, John. I already took care of this answering.
Yeah, thank you very much, Sebastian. So we're going to switch over to Peter Josevic now from Tetrateio, and he's going to talk about running multiple applications through Istio Ingress Gateway. So over to you, Peter. And again, if anybody has any questions, please use the Q&A near the top right of your screen. Thank you.
Awesome. Thank you. I was taking notes all the time Sebastian was talking. I'm like, are you telling me I don't have to like snooze the Docker desktop thing? I can use something else. That was awesome. I took a couple of notes for the tools. It's always good to see like what other people are using and what's popular. So, all right. So my name is Peter. I'm from Tetrateio, and today I'll be talking about Istio Ingress Gateway, specifically how to expose multiple applications through the Istio Ingress Gateway. Now, before I start, I put these things up ahead because I know I usually forget to do it at the end. A couple of resources. We have our own Slack community where you can reach me and everyone else from Tetrateio. We also have free courses on Tetrateio Academy. So we have a free Istio Fundamentals course, and we have a free Envoy Fundamentals course if you're interested in learning about that. We also have a weekly live stream called Tetrateio Tech Talks, where we talk with the people from the industry and we do demos, and it's really awesome. So take a look at that as well. Finally, we're also hiring. So if you want to join us, if you enjoy service meshes, Kubernetes, cloud native things, go to tetrateio.io/careers. We are hiring a lot of positions. So that's why I have only a link here. So feel free to look at that. Feel free to also ping me, join our Slack, whatever, if you want to join. All right.
Peter,
Yes.
honestly, like, I think not a lot of people know about the Tetrateio in general, but like you guys, I heard you guys like one of the top contributors to Istio project and top contributor to Envoy. Is that still the case? Or
Exactly. Yeah. So we have a lot of, we're top contributors, or one of the top 3 at least, for Istio. We have a lot of people working full-time on Istio that are working for Tetrateio as well. A lot of knowledge in regards with the service meshes. So we're all service mesh Istio type of a company, right? All right, so today as I mentioned, I'll talk about how to expose multiple applications through Istio Ingress Gateway. So when I'm talking about multiple applications, what you might hear me say applications, services, workloads, and just to have the same understanding, when I say applications, services, or workloads, I'll typically think of a Kubernetes service. So you have a single Kubernetes service, and those services typically have one or more instances of workloads behind the service. They have pods, right? And those pods can run like APIs, but some backend services. They could be websites. They could be any other service. It doesn't really matter what it is, right? Now in Kubernetes, when you deploy a workload, when you create a deployment or create a Kubernetes corresponding Kubernetes service, typically that service, at least by default, is accessible within the cluster only, right? So it'll get an internal IP address. This is the default Kubernetes service type. Now, in case when you want to access your service from the outside, that's from the internet, you'll have to tell Kubernetes to give you an external IP address, right? You need an external IP address. And the way you do that is you change the Kubernetes service type to load balancer. Now, practically, assuming you're using one of the cloud providers, when you either change the service type to load balancer, or when you create a new Kubernetes service with the type load balancer, what happens on the cloud side is there's an instance of an actual load balancer that gets provisioned, and you get an external IP address. Now, just simply creating this Kubernetes service with the load balancer type, that's not enough, right? You also need some backing service, some workload that will actually handle your requests when they come in from that public IP address. Now, in case of Istio, because I'll be talking, we're in the Istio world now, Istio and Kubernetes world. When we're using Istio, we can use the Envoy proxy as the ingress gateway. So if you're familiar with Istio, Istio also uses Envoy proxy for its sidecars in the mesh, right? So anytime you deploy workloads to Kubernetes, these sidecars will get automatically deployed next to your workloads. Now, the job of this ingress gateway is, what it does, it takes the requests from the public IP address and then forwards them to the workloads that are running behind the Kubernetes service. Now, in order to do that, it needs to have some configuration where we can tell it where to forward the requests. In Istio, the way we can configure the ingress gateway is using the gateway resource. So when you install Istio with the ingress gateway Kubernetes service will use the load balancer type, and it will get a public external IP address. So here's an example of the ingress gateway service that was created. I deployed Istio using the demo profile, right? And this is the Istio ingress gateway service that got created for me, and it had a type of load balancer. And you'll notice there was I got a internal only cluster IP, as well as I got an external IP address. Now, if I would try to either open that IP address or use curl to send a request to that IP address, I won't be able to connect. So the error that I'll get back is connection refused. And that kind of makes sense because we didn't actually configure anything, right? We're just saying, hey, there's a load balancer here, create a load balancer service, here's the IP address. But there's nothing actually configured to listen to the request on that IP, right? This is where this gateway resource comes in. Here's just an example of how a very basic, simple gateway resource looks like, and I'll go through these different sections. If you've done Kubernetes, you're familiar with the format, right? You have the API version, the kind, the metadata, where you can specify the name and the namespace, any labels, annotations, and so on. The first kind of important part in this resource is the selector section, right? And in the selectors, what you do is you can specify one or more labels that you can use to select or target the ingress gateway workload. So if I would list all the pods in my cluster with the app Istio ingress gateway label, what I would get back is that ingress gateway workload that's running in the Istio system namespace. So that's our instance of Envoy pretty much. The second section is the server sections. And what we can do here is we can define which ports we want to expose or which ports do we want our ingress gateway to listen on. In this example, we're exposing port 80, we're naming the port as HTTP, and we're specifying the protocol. Now, in addition to the port information, we also define a list of hosts that we want to expose by this gateway. So in this example, I'm just using a star. However, typically what you would specify here is a host as a fully qualified domain name. So you could do something like hello.com. In addition to the fully qualified domain name, what you can also do is you can use a wildcard character. So we could say star.hello.com. So anything that matches that filter, if you wish, will be the ingress proxy will listen to those hosts. That's why this hosts fields here acts as a filter, and then it only lets through the traffic that matches that host name, one or more host names. Now, of course, these the servers field, it's an array, so you can have multiple of these for multiple different hosts. So once you've created this gateway resource and you apply this gateway resource or configuration, what you've basically done is you've told ingress gateway to listen on port 80, right? So assuming we've done that, and if we try to send a request to that external IP address, we don't get the connection refused error anymore. This time we'll get back an HTTP 404. And if you think about it, this makes sense, right? Because the only thing that we've done is we said, hey, listen to port 80, right? So we open up the port. However, we haven't really told the gateway what's behind there, where to route the request, right? And the way that we do that, the way that we tell the traffic or tell where the traffic should go is we attach the gateway resource to a virtual service resource. So this is the second resource that is fairly popular in Istio, I guess. And the virtual service resource is where you configure the traffic routing. Now, an important part here, and this is kind of a reason that I've created this talk, is it can be very confusing for like newcomers to Istio to actually understand how all this works. The confusing part is that host section here. So we have that host section in the gateway resource as well. And there I mentioned on that slide that that field acts as a filter. And what it does, it tells us which virtual services can we select. Because we've set the host field to star, we set it to star in the gateway resource, we set it to star in this virtual service resource, there's not really anything we filter on, right? So we're just letting everything through. However, if we would set the host field, let's say to hello.com in the gateway resource, we would only be able to select the virtual service that matches that name. So you can imagine having hello.com here, that would match. Having a star, that would match as well. However, having something like foo.com, that wouldn't match, right? Finally, in the HTTP section of the resource, what we do is we define the routes and we actually tell to which Kubernetes service to route the traffic to. So what we can do here is we can say things such as, if the incoming URL starts with a /API, then forward the traffic to hello.svc.cluster.local service. Or we can do the traffic splitting, or we can say 30% to this destination and then 70% to that destination. We can inject failures. We can do a lot of typical Istio features that you heard of, right? This is where you would set most of them. So let me explain more at this hosts filtering thing, because I think that's the confusing part, right? So let's assume we have a Kubernetes cluster, we've installed Istio, and we have an ingress gateway on the left, and we have two services running in a cluster. I'm not calling it anything, but let's say service A and service B. It doesn't really matter for this example. So what we've done is we've configured the ingress gateway. We've created a gateway resource, and we're saying, hey, I want to filter or listen for dev.example.com. I want to listen for hello.com, and I want to listen for foo.com. So practically what you do here, assuming I own all of those domains, is you go to your GoDaddy, name.com, whatever you're using to register your domains. You go there and you say, hey, I want to point my hello.com domain to an external IP address of this ingress gateway, right? So that's how you make the connection from the actual domain name to the actual IP address of your load balancer of your cluster. So when you type in dev.example.com, that will get resolved to the external IP address. Now, in addition to that, we've also configured two virtual services. So assuming one is for service A or the top service, and the bottom one is for the bottom service or service B. So in the top one, what we're doing is we're attaching the gateway. So that's what we do with the gateways field. And then we're also defining the two hosts, right? So we define dev.example.com and we define hello.com. We add those to the list. And then similarly for the bottom one, we add foo.com to the list. So what happens when someone goes to the browser and types in dev.example.com? Now we know that the domain name will resolve to the IP address, right? And that's what that's what the DNS records and the domain registrar do. Then once that request hits the ingress gateway, the dev.example.com host gets matched. So that's good, right? Because we have it in the list. Now, because we also have that host in a virtual service that has that gateway attached together, right? It means that the request will flow to the service or to the destination that's defined in the virtual service. Now, that virtual service also has a section underneath that basically says, route the traffic to this destination. Same will happen if we do hello.com, right? Now, if we send a request to foo.com, the gateway will match it. And because virtual service, right, the second one, the bottom one, has that foo.com defined there, the request will be sent to that backing service. Lastly, if let's say we try to do bar.com, right, or we try to do something else, like an IP address, right, there's not going to be any matches, right, on the gateway, so nothing will happen, right? So you'll basically get back a 404 because we don't have a gateway that listens for their hosts. But even if there's no virtual service, we'll still get back a 404. Questions, and I just glanced over and I see there's a question. I wonder what the use case is for a virtual service with the same matching hosts, but attached to different gateways. If you want to expose the thing from different hosts, maybe you want to have bar.com and then you have another ingress gateway that says foo.com, but you want to go to the same service. That's an example I could think of. I don't know if it's realistic or not. But yeah, there's also a way, like everything that I'm talking about single ingress gateways. You could, of course, have multiple of them, right? you could say, I want to have a dedicated ingress gateway just for our API or something, right? And then you would just do api.example.com, and then we'll go to your API backends. The other scenario with multiple gateways would be having an internal only ingress gateway, right? Because that's what you can do as well. You can deploy this ingress gateway to be accessible from the inside of your cluster or the network only. And then you could configure it in the same way. All right, so quick review. So we have the gateway resource that configures the ingress gateway and allows opening up the ports. And can a gateway point directly to service? No. So gateway doesn't necessarily point to anything. No services. So it's those things are decoupled, right? The way that you point to a service, if you want to expose something through the gateway, is by creating a virtual service and then attaching that virtual service to the gateway instance. But you can't point directly to the service. So we have the gateway resource, configures the ingress gateway and allows opening the ports and setting up the hosts. And as I mentioned, the act of defining how the traffic gets routed, that's on the virtual service, right? And then that virtual service can be then attached to a gateway, and you can then define the hosts in the virtual service that have to be the subset of the hosts or match the fields in the gateway to route to those services. Now, the nice thing about this is that you can define multiple hosts, multiple domains, and then handle them with a single ingress gateway if you want. I've also mentioned there's a way to deploy multiple ingress gateways. So if you want a dedicated gateway for specific hosts or internal only and so on. But the principle in the end is exactly the same, right? One thing to be careful of when you are managing multiple ingress gateways, make sure you use the correct selector labels, right? Because you want to pick the right Envoy ingress gateway workload. Here's just a couple of examples, right? We have a request, hello.com, and then let's say gateway host has a star, virtual service host has a star. You're going to get back the response. It's going to match. Second one is matching as well because second and third one both have stars on those ends. Those going to match. And then you can do like a star.hello.com, for example, and you can see how those things match or don't match. All right, I'm trying to be mindful of time. How about SSL? That's usually and typically the next question that comes up whenever we talk about exposing something on the internet and bringing external traffic in. So how do you configure and how do you set up SSL? How can you provide your ingress gateway the SSL certificates? And how do you configure ingress gateway and tell it to, hey, use the SSL certs for this name? It's actually fairly straightforward. Now, the first step is you have to get the SSL certificate and you have to get the private key, right? And that's the first step that you have to do. You can do self-signed for testing only, of course. You can use Let's Encrypt, SSL for free, Cert Manager, etc. Right? You can get it manually. You can use Cert Manager, which will automate the whole process for you. It'll bring down the certificate and the key. It will renew the certificate for you automatically and so on, right? But regardless of how you obtained that certificate and the key, what you need to do is you'll have to bring the cert and the key inside your Kubernetes cluster somehow so you can reference it or point to it in your gateway resource. The way you do that is you typically create a Kubernetes secret that says, hey, here's my certificate file and here's my private key file, right? Once you have that, once that secret is in the cluster, what you need to do is you need to reference that secret in the gateway resource. And the way you do that is you add the TLS section that says mode is simple. You can also do mutual TLS, by the way. And then you're just saying credential name, and that's the name of your Kubernetes secret where the certificate and private key are in. I go back to that image that we used before. This one is just showing how this works with with the Kubernetes secret and SSL. So everything stays the same. The only difference is you add that section to your gateway resource, and you're basically just pointing to, hey, here's my secret that has the certificate and it has the key. All right, so I have a quick demo. I'm assuming I have a couple of minutes, right? If not, I'll still go about it.
Yeah, we got 7 minutes left. So if you can give us a minute or two at the end, that'd be great.
Perfect,
Thanks.
perfect. All right, so I'll do just a quick demo, assuming this works. There you
Peter,
go. Yes.
I'm sorry. I think there is one very specific thing with secrets for SSL is that the secret have to be in the same namespace as where the gateway is
Exactly.
running.
Yes, exactly. So if you have your gateway, typically, I mean, for production deployments, you would typically have your gateway in a dedicated namespace anyway, right? So you would like provision the ingress gateway in a whatever hello.com namespace for the lack of hello-com for the lack of better naming, right? So you would have that, but yes, you're completely right. If you're using the demo installation or the demo profile of Istio, you would have to create that secret in the Istio system namespace, because that's by default where the ingress gateway gets deployed. You can see it here, but it's all customizable, configurable. So you would typically have this in a dedicated namespace, and then you would also put that Kubernetes secret there. And by putting Kubernetes secret there, you would configure cert manager or whatever you're using to actually drop the secret there. All right, so I have a Kubernetes cluster. I've installed Istio with the demo profile, which means I get ingress gateway and Istio-D, which is the control plane. I've also labeled the namespace, I think, for injection. Okay, so what I'll do is I'll just deploy HTTP bin to my default namespace. So we'll start up, and then what we'll do next, so let me show you the services from the Istio system. You'll notice I have this ingress gateway here, and it has this external IP address. So if I would curl to this address, I'll just get connection refused, right? Because we don't have any, like, nothing is configuring that ingress gateway, right, to listen to anything. So let's see if I have, all right, so I have HTTP bin up and running. So the next thing that I'll do is I will just deploy the simple gateway resource that I showed on the slides as well. Selecting that pod, listening on port 80, star for the host, right? So let's do this one. Now, if I try to curl to that same IP address right now, you'll notice it's different, right? You'll notice I get a 404, and you'll also notice that there's this header that gets added, which is just telling us that it went through that ingress gateway, which was Envoy. So the next step is to deploy the virtual service, because what we want to do in this case, we want to expose that HTTP bin workload on this external IP address. So let's do this one. Just calling in my virtual service. I'm attaching this virtual service to that gateway. I'm saying I don't care about the hosts, right? Just let everything through. And then I'm saying the destination is my HTTP bin service that's in the default namespace. And that's just a fully qualified name for the service. So as soon as this is created, if I curl again, you'll notice that I actually get back, I do headers, right? I actually get back a response from the HTTP bin workload. Now, what I could do is I could say, well, you know what? I don't want to let everything through. I just want to listen to, let's say, hello.com. And the way that you would do this is you would update your gateway resource, and in the host, you would just say hello.com. I want to listen to hello.com. So let's see what happens now. And I'll simulate this with just doing host hello.com. still went through. The reason it went through is because I had the star in the VS, right, in the virtual service. However, if the host is not set, it's not going to work, right? I'm going to get a 404, right? And then the same thing, you could also, what we could do is we could update the virtual service, and typically that's what you would do. You shouldn't have necessarily a star in your, let me update this to hello.com. It would typically pin the virtual service to a specific host, and you do this. And now if I curl, this still works. However, if this changes to, let's say, api.hello.com, so if we have something like this, right, apply. Right, so I've changed the host to api.hello.com. If I curl now, right, this is not going to work. This is not going to work either, right? Because our gateway is not listening to api.hello.com. However, one way you could solve this is to just do, oops, let me do hosts star dot. We could do star.hello.com. So if we do this, if we curl again, this time it works again, right? So it's just a matter of matching the hosts in your gateway resource with the hosts in your virtual service resource, as well as attaching that virtual service to the gateway. All right, so I don't have, that's all for my talk. If there's any questions, I think some of them were already like answered, but
yeah, thank you very much, Peter. I'll ask a couple of the questions that came up in chat here. So first of all, can a gateway point directly to services, or can it only go through virtual services?
It has to go through virtual service. That's the separation of concerns. It has to go through, yeah.
Okay. And then how would high availability setup affect the configuration that you've shown us here?
It actually wouldn't, right? I mean, I'm trying to understand the question, but if, let's say, if you want to scale up your ingress gateway, right? It's a Kubernetes deployment. So you could just say replicas equals 10 or whatever you want, right? And that's how you would scale up, right?
And so then the load balancer takes care of the other half of that equation.
It's everything else is just Kubernetes, right? The ingress gateway is just a Kubernetes service in a way that points to a set of pods, right? The actual configuration for that gateway is done by the label, right? So
cool.
Yeah.
I have one question of my own. Do you know anything about how Istio gateway relates or doesn't relate to the upcoming Kubernetes gateway work? Is there a relation between Istio gateway and Kubernetes gateway?
I don't think there is.
Okay.
I'm not like I've heard of it, but I don't know if it relates to, if it's in any way related.
Fair. Okay.
Yeah.
Well, thank you very much, Peter. I really appreciate your presentation, and thank you for your time. And everybody, if you could take a moment to fill out our survey in the chat there, and we will see you hopefully next month. Thank you very much, everybody.
Thanks
Thanks,
you all.
everyone.